viewers, welcome back to the channel everyone, and in this video we are going to discuss about linked list and its implementation in C programming language. Linked lists are basically a data structure in which each item stores the data and also stores a link to the next item in the list. Now in order to reach any item except the first one, you need a item in the list before that particular item. In this you can see that in order to reach an item in linked list, we need to reach an item before that. Now you might be thinking, if we have arrays, then why do we need linked list? Now there are different kinds of linked lists. There are double linked lists, circular linked lists. Now linked lists themselves are used in implementation of many other data structures. Now that we know about linked lists, we will see how linked lists are different from arrays. And why do we need a linked list when we have an array, or what is the difference between the linked list and an array? Now let's say I need to store 3 items and I have an option of using an array and then a linked list. Now in array I need to allocate a block of memory and then put the items in that array, and each of these are stored at indices 0, 1, 2. Whereas in linked list I can store the items in the linked lists in different locations in the memory, but in my code I can, or in my program I can get them, or I can use the items without allocating continuous blocks of memory. Let's see how we can implement a linked list in C programming language. To start with, I have a linkedlist.c file. In this file, there is nothing special, just some basic stuff that include a standard input output.h file and our main function. Now let's create a node in a linked list. So I'm going to begin with a structure. This is called node. Generally, an item in our linked list is called node. Each node has 2 variables, you can say. The first one is the data that's for the node, or the data that the node contains, and the second one is a pointer to the next node. Integer, number, node, next. In our main function, I'm going to create 4 nodes. And now I'm going to assign values to the number variable of these nodes. Now that we have the data in the nodes, let's create a linked list. n1.next, n2, and same thing with n2 and n3. In the n4, we don't want there to be any next node after n4, because n4 is the last node in our linked list. Other words, n4 is the last item in our linked list. We are going to set the next value for this 4th node, or the last node, is null. I'm going to write a function here which returns a node. Now we need a loop to loop through the values in the linked list. So this is going to be a while loop. In this while loop, we are going to check whether the node has any next value or not, or mnode.next should not be equal to null. and also we are going to update the value of this m node. Finally, we are going to return this m node. The main function printf, I'm going to use printf function to print the number in the very last node of our linked list. I'm going to use this function get last node, then pass the node. In this case, I'm going to pass the very first node, or n1, access the number variable of that node. You can say it says the last number in this linked list is 40, and if you look in the n4 node, it is 40.